Hello and welcome to Dr. D.O. Patil Vidyapit Center for Online Learning. I am Professor Anand, course coordinator for this Performing Analytics with Python. Learners, in this session, we are going to learn about unit number 6 of Performing Analytics with Python, that is Mathematical and Scientific Applications for Data Analysis. Before we start, let's have a quick look at the agenda for this session. In this session, we are going to cover about NumPy and SciPy, introduction to NumPy and SciPy libraries, what are the universal functions available in NumPy and SciPy libraries, and we end with this summary. So, let's start with introduction to this unit, that is unit number 6. NumPy introduction. A Python package called as NumPy, that is a numerical Python. Basically, it is a library made up of functions for performing or for handling arrays and multi-dimensional arrays. So, NumPy stands for numerical Python, which consists of the functions which are used to handle multi-dimensional arrays. To work on multi-dimensional arrays or to handle multi-dimensional arrays, NumPy provides built-in functions. Now, let us see what are the operations that I can perform with NumPy. As a programmer, I can carry out the following actions with NumPy. Operations on arrays that are logical and mathematical as well. I can perform the Fourier transformation for manipulating the shapes. Means there are routines, there are functions and Fourier transformation for manipulating the shapes. I can perform the activities connected to the linear algebra. There are built-in linear algebra and random number generating routines in NumPy. So, basically the NumPy will contain the functions for performing the Fourier transformation, performing linear algebra and built-in linear algebra functions and random number generating functions which are available in NumPy. So, these are the basic functions which are available or operations that I can perform with NumPy. The n-dimensional arrays type known as the ND array is the most significant object defined in the NumPy library, and the collection of identically categorized things is described in NumPy. A zero-based index is used to access the items in the collection. So, if you want to access the items in the collection in the array, we have to use the index, and the indexing starts with 0. So, each element of an array, of an ND array, occupies a memory block of the same size. Every component of the ND array is an object of the data type of the same data type. So, all the items in the ND array are of the same type and all blocks in the ND array are of the same size. So, the basic ND array is created using an array function in the NumPy in the following way. That is NumPy dot array. In the parenthesis, we need to specify the object name, we need to specify the data type name, we need to provide the additional attributes like copy, order, sublook and n-admin. So, what are these attributes? Let us look at them one by one. First one is the object. Any object exposing the array interface method returns an array or any nested sequence, that is the object. D type, that is the desired data type of the array that you want to create, that is optional completely. Copy, the copy attribute is again optional and by default it is true. The object is copied or not. The next attribute is the order, that is C row major or F column major or any default. So, it can accept the values like C row major, F as a column major or A as any or default item that it can accept. Sub OK by default returns an array forced to be a base class array. If true, the subclass is passed through. The next attribute is NAdmin. NAdmin specifies minimum dimensions of the resultant array. What would be the dimensions of the array that will be specified, that would be returned by NAdmin attribute. So, these are the attributes which I can provide while creating the ND array. Some of them are optional and some of them are required, necessary. So, let us have the look at the example. So, here first we need to import the NumPy library. As we can see, we can give any name, as say import NumPy as MP. I have imported the library NumPy in my file as NP. So, now I can use the NP to represent the libraries of NumPy. So, A is equal to, here I am creating the ND array, like name of the array here is I have given as A is equal to NP is the object of NumPy. A is equal to NP dot array. In the parenthesis square bracket, I have to specify the values to the array, that is 1, 2, 3. So, all we can see that all other attributes like order, copy, sub OK, they are completely optional. So, here I am just providing the integer values. After that, if I say print A, what it will print? It will print as in the square bracket 1, 2, 3, that is the values of the array which I have created with the array name as A. So, this is a simple way of creating an array. You just need to use the object name dot the function name array, and in that specify the values in the square bracket to your ND array. Second example, if I have to create more than one dimensions, then how I can create? So, the first one, as you can see, there is a single dimension, means what? It contains only a single row. But if I have to create an array of matrix, that is multiple rows and multiple columns, then how I can create? Again, it is very simple. First, you need to import the NumPy library as say NP, or you can give any name here. I have used as NP here. After that, like in the above example, you can create an array of multidimensional as A is equal to NP dot array in this rounded bracket, and in this square bracket I can provide the values for the first row and column, that is 1 and 2, comma, again in the second square bracket I have to provide the values for the second row and the second columns of my second row. So, here it will create a matrix having 2 rows and 2 columns, and if you try to print by using the printf statement or print statement, print A, what it will print? It will print the values in terms of matrix that I have created, an array of having 2 rows and 2 columns, each row having 2 columns, that is 1, 2 and 3 and 4. So, this is a very simple way of creating one dimensional and multidimensional array in Python by using the ND array. Now, minimum dimensions means what? How we can create an array with by specifying the dimensions. Like we have to import the NumPy as an array, as an object name, like import NumPy as MP. A is equal to NP dot array in the rounded bracket, in the square bracket specify the values as 1, 2, 3, 4, 5 and complete the square bracket, comma, now specify the NAdmin, that is NDIM or NDMIN is equal to 2. So, what it will do? It will create the array of minimum dimensions 2. So, if I print by using the print function, the output is been displayed in the slide as an array having the dimensions as 2, that is 1, 2, 3, 4, 5. So, that is here I have specified the dimensions as 2. Now I can specify the data type as well by using the D type is equal to complex as well. So here we can specify the data type for your array by using the attribute called as D type. So here import NumPy as NP, A is equal to NP dot array in the rounded bracket, and in the square bracket specify the values as 1, 2, 3, and here I want to create an array of complex numbers. So here I have provided the data type by specifying as complex, and if I try to print the value of this array, then what I will get? I will get an array of complex numbers that you can see here. Output is equal to in the slide. Now NumPy array attributes, that is ND array dot shape. So there are the NumPy provides me multiple attributes. So for example, shape. So this array attribute returns a tuple consisting of array dimensions, and it can also to be used to resize the array. So if you want to resize the array, I can use the shape attribute of the NumPy. How? For example, import NumPy as NP, A is equal to NP dot array. Again in the same way, provide the values in a rounded bracket, in the square bracket 1, 2, 3, square bracket complete, 4, 5, 6, square bracket complete, again the square bracket complete and the rounded bracket complete. If I print the shape of the array, what would be the shape? The shape of the array is 2, 3, that is 2 rows, 3 columns. How it is been done? Because here I have provided the values as 1, 2, 3 and 4, 5, 6. So here if I say here print A dot shape, shape means what? The shape attribute returns a tuple consisting of array dimensions. What are the dimensions of this array? So dimensions are, that is 2 rows and 3 columns. So this resizes the ND array. If you want to resize, if you want to change the size of the array, how it can be done? It can be done by using, again by using the shape. For example, import NumPy as NP, A is equal to NP dot array. Again here I have created the array with passing the values of 1, 2, 3 for the first row and 4, 5, 6 for the second row. And if I say here A dot shape is equal to 3, 2, so it will create an array of having 3 rows and 2 columns, as you can see in the output array of this array. So the next one is NDEM, that is ND array dot NDEM. So this array attribute returns the number of array dimensions, that is, for example, NumPy, import NumPy as NP, A is equal to NP dot arrange. If I say here 25, it will print as the values from 0 to 24 exclusive of the value. So the arrange attribute of the NumPy of the ND array will create an array of the values, of the range of values that you have specified with the arrange attribute of the ND array. So as you can see here, if I say np dot arrange, if I specify the values as 25, then it will create the array having the values ranging from 0 to 24, and if I provide the value as say 10, then it will create the value the array with the values ranging from 0 to 9. So in this way we can create an array with a specific range by using the arrange attribute of the ND array. So if I say 24, then it will create an array with the values ranging from 0 to 23. And if I say, if I want to find out what is the dimensions of this array by using the a dot ndim, if I say print n dot dim, so it will give me output as 1, because this is a single dimension array. Means what? It is an array having a single row. So if you want to find out the dimension of your array, how many rows and how many columns are there in your array, you can simply use the attribute ndim with the object of the array, like in the example a dot ndim. Ndim means it will return the attributes, the dimensions of your array in terms of rows and columns. So now if I have to reshape it, for example, b is equal to a dot reshape 2 comma 4 comma 3, and if I say print b, so now b is having 3 dimensions. So in the same way, if I use numpy dot item size, this array attribute returns the length of each element of an array in the bytes. For example, the d type of the array is int 8, that is 1 byte. So if I write a code like numpy, import numpy as np, x is equal to np dot array, and if I specify the values as 1 2 3 4 5 in the square bracket, and if I specify the data type as say np dot int 8, so int 8 occupies 1 byte of memory. Okay, so now if I print x dot item size, so the output will be 1, means what? Every number occupies as the size as 1 byte, since the data type I have specified as int 8. So int 8 occupies 1 byte of memory to store a single element. So that's why you can see out the output as 1. So if you want to find out the length of each item, what is the length of each item in terms of its memory occupation, then I can use the attribute, that is item size, with the object of array like np, like the x dot item size. X is the name of the array and item size is the attribute of the nd array. So these are the different attributes that I can use with the nd array. Again, if I have provided the data type as float, so float will contain 4 bytes of memory. So again, if I have to find out what is the item size of each element, by using the printf x dot item size, I will get as 4, since the data type float will occupy 4 bytes of memory to occupy each element. So if you, in the same way, the numpy dot empty, it creates an uninitialized array of specified shape and data type. So if you want to create an empty array, I can use that numpy dot empty. So it uses the following syntax or following constructor, that is numpy dot empty, specify the shape, specify the data type and specify the order. So here I have specified as float and order as C. In the same way, if you want to create an array which is initialized with zeros, I can use numpy dot zeros attribute. So it returns a new array of specified size filled with zeros, like numpy dot zeros shape. I can specify the shape to create how many rows and how many columns that I want to create. I can specify the data type of my array items. I can specify the order as well. So array of 5 zeros can be created with the default data type is float, like say x is equal to np dot zeros of 5. So it will create an array having 5 elements initialized with 0. As you can see in the slide, the output of this print x will have an array having 5 zeros, since I have created the array with 5 zeros by using np dot zeros 5. So np dot, if I want to create the array initialized with ones, I can use the ones attribute with the array object, like the numpy dot ones returns a new array initialized with ones. Here I can specify the size, I can specify the type and I can specify the shape as well, like numpy dot ones shape comma d type comma order. So in this way I can create an arrays either of empty values, I can create an array with zeros, I can create an array with ones by using the attributes like empty, attributes like ones, attribute like zeros as well. Depends on the application, we can use different attributes of the nd array with the array object. Now let's understand the SciPy, that is SciPy introduction. The scientific Python, it's a scientific Python open source library. Basically, SciPy is a scientific application. It's an open source library which is used to perform mathematical and scientific and engineering computation. So, basically it is used for performing complex mathematical, scientific, engineering and mathematical computations. It is a library built on the top of a NumPy arrays. So, it is built on top of NumPy array. So, it means that it will use some of the basic functions of NumPy, since it is built on the top of NumPy arrays and provides many user friendly and efficient numerical functions for integration and optimization purpose. Let us look at the data structure. The basic data structure used by the SciPy is multi-dimensional array provided by the NumPy module. Like I said, that it is built on the NumPy library. NumPy provides some functions for linear algebra, Fourier transformation, random number generation, as we have seen in the very first slide. That is the operations which I can perform with NumPy, that I can perform the Fourier transformation, I can perform linear algebra, I can perform the random number generations as well. So, these are some of the functions which are provided by NumPy, and by default all the NumPy functions have been available through the SciPy namespaces. So, by using the SciPy libraries, I can have access to all the NumPy functions that we have discussed. I can access them through the libraries, through the object of SciPy as well. So, there is no need to import the NumPy functions explicitly when we are imported the SciPy library. So, once you imported the SciPy library, we do not need to import the NumPy library, because the SciPy library is built on NumPy. So, all the functions which are available in the NumPy library, they are automatically available in the SciPy library. So, once you import the SciPy library, you can have access to all the attributes, all the functions which are provided by NumPy library as well. Now, let us look at the NumPy vector. A vector can be created in multiple ways. Some of them are described below. Let us consider the following example. Import NumPy as NP list. Here I am creating the object of list. List is equal to, in the square bracket, 1, 2, 3, 4, and if I say here ARR is equal to NP dot array, in the bracket, if I specify the attribute as list, so here it will create an array from the list. If I print the values of ARR by using the print function, I will get as the array as 1, 2, 3 and 4. So, in this way also I can create the NumPy vector. Now, let us understand the intrinsic NumPy array creation. The NumPy, like I said, that has built-in functions for creating arrays from scratch, and some of these functions are explained below, like say using zeros. The zeros function will create an array filled with zeros values with the specified shape, with the specified data type, and the default data type is float 64, as we can see that. And let us consider the following example here. Import NumPy as NP, print NP dot zeros, specify the values in a rounded bracket as 2, 3, and OP, that is output, is array of zeros. So, it will create an arrays of having 2, 3. Using zeros or using ones, the ones, that is shape function, will create an array filled with the values ones, and it is identical to zeros. So, in all the other respects, it will create an array filled with ones like zeros. Import NumPy as NP, print NP dot ones in the rounded bracket 2, 3, and if I try to print, then what I will get here? I will get the arrays created with ones and 1s only, that is 1 1 1 2 comma 3. Using arrange, like I said that the arrange function will create an arrays with regular incrementing the values, like we have seen in the previous slide. If I say here as np dot arrange, so what it will do, it will create an array of having values from 0 to 6. Defining the data type of the values, so here I can define the data type of the values by using the d type as well. We have seen this in the previous slide as well. Import numpy as np and array name is equal to np dot arrange, specify the range, that is 2 comma 10, d type is equal to np dot float. So what this will do, this will create an array having values starting from 0 to 9, exclusive, that is 10 will be exclusive. Now let us understand the universal functions, that is U functions, which are available in NumPy. So in NumPy there are some universal functions that operate on element wise on the array. So if you want to operate on each of the element of your arrays, then NumPy provide you the universal functions, enabling you to apply the same functions, apply the same operations on every element of the array or in the array without the need for explicit looping. So without defining the loop, just we call the function, that function will automatically perform its operation on every element of the array. We don't need to define the loop. So that is the main advantage of the universal functions. If you want to apply the function on each element on your array, so definitely NumPy will provide you the universal functions. Let's see them. What are the functions? What are the universal functions available in NumPy library? So applying the universal functions for element wise operations. If you want to compute the element wise squares, if I want to compute the element wise squares of all the elements of my array, then what I will do here, I will just call the function that is square of my array. So here I can say np dot square, in the rounded bracket I can provide the name of the array as, say in this case, as ARR. So what happens here? So all the elements, they are automatically calculated its square values, and it will return, it will be stored into the squared underscore ARR. So if I print the squared underscore ARR, what will be the values? The values will be the square numbers of all the values of my ARR array. So this will compute the element wise square root. So if you want to compute the square root, then I will just call the sqrt function on the array. So this will calculate the square root of all the elements of my array, in this case that is ARR, and it will store into the sqrt underscore ARR. In the same way, if you want to calculate, if you want to perform the exponential on all the elements of your array, then I can just call np.exp, and I have to pass the array name as a argument to this np.exp built-in universal function. And if you want to perform, if you want to calculate the element wise sign, then I can call the np.sign function, and I have to provide as a array name as argument to the np.sign function. So in this way I can calculate the element wise sign as well. Now let us understand the aggregation and reduction. The NumPy arrays also facilitates aggregation and reduction operations that summarizes the data. So for example, functions like numpy.sum, I can find out the sum of all elements of my array elements. Numpy.mean, it will find out the mean from all the elements of my array. If I use the numpy.min, it will find the minimum value from all the elements of my array, and if I use numpy.max, it will find out the maximum value of all the elements or from all the elements of my array. So that will allow you to compute the summary statistics efficiently. So these are some of the aggregation and reduction functions available with NumPy as well, that is sum, min, mean, max, etc. So for example, computing the summary statistics or compute the sum of all elements, I just need to call np.sum and specify the argument as array name. If you want to find out the mean, I have to call the np.mean and providing the argument as array name. In the same way, I can call the np.max and I have to pass the ARR as the argument to the np.max function as well. So these are the aggregation and reduction functions which are provided in the NumPy as well. Now let's understand the array broadcasting. What do you mean by array broadcasting? Arrays, the NumPy supports broadcasting, which allows arrays of different shapes to be combined in the operations. So this is possible that we can combine the arrays of different shapes, and this feature simplifies the computations involving arrays with different dimensions. So we can combine the different dimensions into a single array. For example, if I say here as ARR underscore 2D is equal to np dot array in the round bracket and in the square bracket, if I pass 1 comma 2 comma 3 square bracket complete, and again if I pass in the square bracket 4 comma 5 comma c square bracket complete and rounded bracket complete, and if I say here scalar is equal to 2, the resultant array is equal to ARR underscore 2D plus scalar. So what it will do? It will add 2 to each element of the array. So if I specify as scalar as 3, so what this will do? It will add the value 3 to every value of this array. So here I have added scalar is equal to 2. It means what? The values of my array will become, that is 3, 4, 5, 6, 7, 8. So in each element the value 2 will get added. Now transposing an array. Transposing means what? Transposing of matrix means obtained by moving the rows of data to the columns and column of the data to the rows. So this is called as transposing of the arrays. So when you convert the columns into rows and rows into columns, that is called as array transposing. So for example, A is equal to np dot array. In the round bracket, I pass the values as 1, 2, comma and 3 and 4. If I print, what it will do? It will just print the array having 2 rows and 2 columns, like in the first array, first row 1, comma 2, in the second row 3, comma 4. But if I have to transpose the arrays, then I will just call the function that is np dot transpose, and I will pass the array name as argument to the np dot transpose function. So now the values of columns becomes rows and the values of rows becomes columns. As you can see, after calling the transpose function on the array, the values of my array becomes 1, comma 3, 2, comma 4. That is, it will just move the values of column to row and from the row to a column. That is called as transposing of the array element. That is possible by simply calling the transpose function on the array element. Now, like I said, that we can combine the two arrays into a single array, that is concatenation. So NumPy offers functions to concatenate and stack the arrays, allowing you to combine a data from different sources or create multi-dimensional arrays. So here we can create the array from different sources. For example, A is equal to np dot array, specify the values as 1, comma 2, 3, comma 4, and concatenated array is equal to just call the function that is np dot concatenated is equal to, so np dot concatenate, in the bracket I specify the array name 2 times. So what it will do? It will just concatenate this array 2 times. So it means now the values of array will be 1, comma 2, 3, comma 4, 1, comma 2 and 3, comma 4. Means what? It will simply concatenate 2 arrays. So here I have concatenated the same array twice. So with this, we come to the end of this session. I hope you have enjoyed this session. Thank you for watching.